Hi, and welcome to another demonstration of using the Virtual Vulcan. In this demonstration, what I would like to do is create the equation A times not B plus C. A times not B plus C. So as I look at my equation, I realize that I have a times sign, a plus sign, and a not sign. I need all of those chips on my board. So I'm going to go to chips and pick my and sign. 7408 is my and sign. I need a not sign. Where would I find the not sign? 7404 is my hex inverter. 7404 is my not chip. And then I need my OR sign, which is going to be 7432. Now again, as you learn these, if you double click on these, you can see what the chip is. That is an AND chip, where two inputs, one output, two inputs, and so on. That's my power, that's my ground. 7404. I have my power followed by an input, output, and so on. Then of course my 7432, power, ground, two inputs, output, two inputs, output. First thing I'm going to do is create A times not B. But before I can do anything, I need to make sure each chip here is powered and ground. So I'm going to connect power to the top row, and then I'm going to connect any of the power holes to the top hole for each chip. Now I have power going to each power pin, but I also need to make sure I ground it. When I ground, I like to use one of the bottom rows and then connect the grounding wire for each chip into that row as well. So what I have now is three chips, all powered, all grounded. First thing I'm going to do is do A times not B. I'm going to use this hole for A, this hole for B, this hole for C. So for me it's going to be A, B, C. I need to do A times not B. If I look at my times chip again, I'm going to put A into here and not B into here, because this will multiply them and send out the answer. So I need A in this hole, not B in this hole. Well, A will be the easiest. I'm going to connect a wire from A, and I'm going to put it in this row because these are all connected. The next thing is I need to put not B into the following row. Well, to get not B, I'm going to need my not chip. Again, if we look at the not chip, this pin is your input, this pin is your output. So I need a B to come in so that not B will come out. So I need to not B. Here's my B, and I'm going to put it into my not chip. This is now B going into 7404. The pin after it right here in any of these holes will be now not B coming out. What do I want to do with not B? I want to take not B and multiply it with the A that's over here. So if we watch carefully, I'm going to take not B, which is any one of these now, and put it in to the second input over here. I have A going in, I have not B going in, The next hole is that answer. That answer, A times not B, I want to add to C. 7432 is my adding. I can pick any combination here. I'm going to put A times not B into this one, and then I'm going to put C into this one, and my answer will be not A not B plus C coming out. So I need to go get A not B. There's A, there's not B. This answer, these pins, these holes right here are A times not B. That's what I want. So I'm going to put a wire here and bring that wire into one of the inputs here. This is not it. This is A not B going in to my plus sign. The one next to it is I want C. So I'm going to go A, B, here C, and I'm going to bring C into the holes right next to it. So I now have A not B plus C. Here comes my answer to that equation, and I'm going to put it into one of these inputs. I'll just put it in the first one. So here we go. Let's check to see what kind of lights I can get. First of all, I'm going to turn them all off. And remember, this one here is your master on and off. Right now it is turned off. I'm now going to turn this on. That means it's working. Now let's see what happens as I switch A, B, and C on. A is in the 8th, B is in the 7th, C is in the 6th. Flick on A, I get a light. Click on B, I do not. Click on A and B, I do not. Click on C. And if you do the truth table of this, you'll realize that you are getting the truth table for A times not B plus C. And again, I hope this helps. Let me know what else I can get for you. Good luck and keep up the good work.